Evaluate the expression without the use of a calculator. The expression we're working with is log of 1 over 10 million. So the strategy that we're going to use to simplify this logarithmic expression is to write it as an equation to start with. So I'm going to say I don't know what this expression equals. Let's say it equals p. I'm using p for power or exponent. And once I write it as an equation, I'm using this, which I pulled from the definition of a logarithm. And the logarithm is defined in terms of its inverse, an exponential. So this gives us a way of coming up with an equivalent equation that is in exponential form. So here we have a log equation and the equivalent exponential equation. So the base of the log is the base of the exponential. The log equals y, which is the exponent of the exponential. And the exponential equals x, which is the value that is inside the log. So this pattern allows us to convert back and forth between log equations and exponential equations. So let's do that for our example. Log of 1 over 10 million equals p. So the first thing that's a little bit strange here is that in our definition we have in a smaller font, lower, we call that a subscript, this value of b, and in the example that we have, there is no number with a smaller font in that subscript position. And when there is no number in that position, we assume a base of 10. It's called a common log. It is the common base for us to use. So this equation would be the same as log base 10 of 1 over 10 million equals p. So we assume that that base is 10 when we don't have one listed. So now that we know the base, we're going to use that as the base of our exponential. So we're going to use 10 as the base. Then our logarithm equals p, and that is in the position of the exponent for our exponential. So we're going to use p as the exponent. Then our exponential equation is going to equal what is inside of the logarithm, substituted inside of the logarithm. So that's going to be 1 over 10 million. So we've rewritten this we've rewritten the logarithmic equation as an exponential equation. So now when it's in exponential form, we're going to try to figure out what that value of p is. So as we look at this, we have 10 to a power equals 1 over 10 million. Let's write it without all the highlighting. 10 to a power equals 1 over 10 million. I got my comma in the wrong spot there. So we want to figure out what that value of the exponent is. And one strategy that we could use is one that we've seen before, relating the bases. If we can write these both with a base of 10, we'll be able to figure out what that exponent is. So 10 million, you can see it has all those zeros. I can write that as a power of 10. So 1, 2, 3, 4, 5, 6, 7. So that's 10 to the 7th power. And then I can move this to the numerator using one of the properties of negative exponents. That's 10 to a power equals 10 to the negative 7. And now that I have these bases being the same, I can see that the power is negative 7. So P is negative 7. And this log expression, log of 1 over 10 million, is equal to negative 7. Thank you for checking out my videos. Have a great day.